Anyway, this is the control center for the project as a whole, and there's all of this wiring is going to be done for you. Okay, so this is basically going to be the way you find it in your kit. This is what you're going to see, with the exception of some pigtails that I will have put in here, so that you understand what hooks to what when you bring your control wires down to it, or up to it, should I say. So to kind of recap, what's going to happen is the wires are going to come from the inside of the cooler, and then they're going to pass behind the compressor, which would be back here, and they're going to come up here, and then you're going to land them at these different locations that I earmark for you. Okay. I actually have one for a customer a few feet away, and I'd show you the tags, but I don't think it's really going to be all that necessary for me to show that to you. It'll be self-explanatory when you see it. But just to give you a little idea about what's going on here is this is our 12-volt power supply. We have hot and neutral for our AC voltage. We have 12-volt plus for our low voltage, 12-volt minus, and then we have a number of relays depending upon which appliance we're going to run off these. Now, of course, the controller does have relays in it, but I like to try and preserve the life of that controller for you, so I offload the capability of those relays onto these relays and only use the very, very small milliamp signals that they need to trigger these relays. So these are actually 4 different relays, because this system is set up for full-time fan operation and does include a heater. I use fairly robust relays for both the heater and the air conditioner, or the cooler. These things would actually be capable, current-wise, of actually running an air conditioner. They're pretty much more power than what you really need. Okay, so what we're going to try and do is just basically center this assembly. Okay. And the assembly does come with two-sided sticky tape, which you'll see here on the back. Okay. Now the two-sided sticky tape is not going to hold this thing by itself. So this two-sided sticky tape only is really here to help you get started with putting on the control center on the back. So I previously wiped this off. You want to make sure that this is clean and relatively free of dust. Okay, now look, this thing doesn't have to be exactly level, it doesn't have to be perfect. You just have to get it on there, and I'd say get it on there, relatively straight if you can. Okay, so I'm going to put it right about there, I think. Okay, there we go. And there's a rib up here on the top. You'll notice it's stuck on there already. Okay, so this is pretty good. It's a 3M brand sticky tape that I use, and so this stuff's pretty good. Okay, so that's basically going to be the way this thing sits on the back of your cooler. All right. So what we're going to do next is we're going to come back here with a 3/16 drill, and we're going to drill it out in a couple of locations so that we make sure that we're not just dependent upon the tape that we're using to hold this. And actually the tape would hold it probably for a considerable period of time. I've taped a lot of heavy stuff like this before with this tape, but don't leave it that way. That's not the plan. And you're going to have screws to go ahead and mount this. So I'm going to go ahead and stop this video. I'm going to go set up the drill. I'm going to come back here with the nuts and bolts, or the screws and the nuts, and we'll get this thing attached. So we'll be ready to go to the next step. Okay, so we're back working on the on mounting the control center, and now what I'm going to use actually is an 1164 drill. Okay, now you may not have one of these 1164. That's cool. You can use 3/8 here if you want, but since I'm going to be using number 8 screws, really the more correct size is 1164, and I'm kind of a stickler for that kind of thing. So that's what I'm going to use, but like I said, a 3/16 is very, very close. and you can go ahead and use a 3/16 if you want. Now, remember that we're going to actually be making some metal chips here, so what you don't is you really don't want the metal chips falling into your electronic components. That would be no bueno. So we don't want to do that. The most sensitive thing here, almost everything else is pretty much sealed and will shake out, is your power supply, okay? And so we really don't want to get anything in the electronics that would short it out. Now we can take this off and or cover it up or move it out of the way. I'm not going to do that. It should be fairly easy to drill a hole in it. But remember from putting the hole down here, this is high strength sheet metal, so it can be a little bit cantankerous to work with. We don't really need to worry about measuring or putting the holes in any particular spot. The DIN rail here is slotted or does have holes in it. Now I buy these from a bunch of different manufacturers, so if yours doesn't have to happen to have a hole or a slot, it's okay, just drill right through it and drill through the back, and that's what we're going to do here right now. So we're going to just start with our first hole. I'm just going to pick this about mid-span. Okay, and there's my first hole. Now, like I said, remember, I have a piece of sacrificial wood down here because I don't want to drill through my router table. So always be careful, you know, when you're doing this kind of stuff. Now, there's going to be no components that are covering this up, so it doesn't really make a difference whether you put the screw head or the nut, you know, on one side or the other. But what we're going to do is we're going to grab a washer and a nut, and then another one of these fender washers. You can't really see what I'm doing. I'll show you in a second. And we're going to go ahead and we're going to just through bolt it to the back side. Now, almost every nut in this in my kit is going to be 1132s, okay? Because again, these are number 8. These are number 8 screws. So you just hold it with a wrench or a 1132. You know, 1132 socket if you have it. Sorry if this isn't exactly centered. And just go ahead and screw this guy down tight, okay? Remember, there are small screws, so you don't really have to get them too tight. You don't want to ruin them. Okay, but that's going to more or less permanently hold the assembly here to the back. And if you need to see the back side of it, there it is. So there's a fender washer, and then it's an aircraft grade nylock type nut that we're going to use. Now, you probably don't need to watch me put in all 4 of these, but we're going to want to get one somewhere in the center, okay? And so, but what I don't want you to do is I don't want you to really fool with any of this wiring because you probably wouldn't know where to put it back. But the nice thing is that these 2 relays here are on mounts, okay? And how the DIN rail actually works is, if you look at it from the side, okay, you can see that it has these 2 lips on them, okay? And so typically in a DIN rail installation, from top to bottom, you have something that clasps over and then snaps on from the back or from the bottom, okay? And that's what these do, see? So they're held on, and you can see these little red tabs down here. Sure hope you can see that. Okay, so look at little red tab, okay? And these are spring-loaded, so all you need to do here is you just need to pull them down a little bit. You can use a screwdriver if you want to leverage them and get them up. My fingernails are strong as rocks, so it's pretty easy for me. So there you go, and you can just tilt these guys up, and you can just kind of move them out of the way a little bit, all right? And so that's how you're going to get to that hole. Now, like I said, if there's not a hole there, it's not that big of a deal. You can just make one, all right? So that's what I'm going to do. Okay, so we've gone ahead and we've gotten through that piece, all right? So we're good to go there. And then there's going to be another one that we're going to need over here on this end, right? So I'll zoom back out a little bit. Okay, and we're all the way through. All right, so 3 is really all you need. And just like before, screw and a washer. Try to pick up some of these little goobers here. Okay, push that through here. And we grab another washer, put it on the back. Move this over a little bit. I'm not too used to working in a demonstration mode for people, so pardon me if I fumble through it a little bit. And the same thing, depending upon whether I get you Phillips or an Allen head type button head screw, I just use something that I can hand tighten this with. You really don't need, you don't need a wrench or a ratchet. You don't need anything that's really that powerful. And you just snug this guy down. Alright, so now we got 2. I don't think you probably have to watch me put in the 3rd one. I just blew out the channel of the DIN rail. Again, I don't want anything to go back into this power supply. And then you reset these guys. They just line right up and they go between these 2 blocks, okay? And you slide them down to where they catch on the top, and you can feel that, all right? And then you just snap them in place. So catch and snap. Now, if you're not paying attention to what I'm doing, and you look at the tops of these, there's another little red catch, and what that does, though, that holds the physical relay on there. Okay, because the relays are not attached to these; they're just attached with another snap, something like these guys here on the bottom. So don't take the relay off because you don't want to drill through and mount the actual mount. Okay, you just want to free the mount, move the relay out of place, move them both. Okay, and get in there somewhere to put your screw in. Now, in some cases, depending upon what configuration we have, I might only have one of these larger brick type relays. It's okay, just lift it out. If you needed to go somewhere else, we can actually pop these guys. They're very difficult to pop off now because now they're on a flat assembly. But with a screwdriver, you can pop them, and I'll go ahead and show you how to do that just for the sake of argument. Okay, so these assemblies are typically bridged. Okay, so all the reds are going to be bridged together. So even though you pop one, you're going to need to get all of them at the same time, basically, to get this assembly out. Okay, and there you go. See, and that would take out the whole series. Okay, and they're pretty flexible, but remember they are shorted together. There's a shorting bar that goes right up here that is going to keep all these reds as a group shorted together so that each one acts as a terminal for the 12-volt positive. The same would hold for the green, the same would hold for the white, the black, etc. Now some of these, again, just so you know, are independent. Just because they're next to each other doesn't mean they're bonded together. Like this orange, for example. Okay, see, that's totally independent. And so just so you understand a little bit about how the logic works with one of these things, most of my entry points or my driving signals, these are going to be my digital input signals from your controller, are going to come into the control center in this area here, okay? And then they're going to do their magic or be powered by whatever and go to whatever relay and power them back. And so from here over, this is all pretty much low voltage stuff, with the exception of the line voltage, which goes to both run the cooler and would also go to run the heater. Okay, so those are line voltage appliances, or 120 volts. Also depends on what country you're from. I mean, some of these can be 250 volts for my friends in Australia and such. And then on this side, basically, of the white neutral blocks, these are going to be line voltage terminals. Okay, so these guys are going to go. This guy's going to go power your heater, the orange one, and this one is actually going to power the compressor, is going to power the cooler. So and I tend to put them more or less in logical groups and try to match them with some wire colors to make it easier for you. So the green is going to be the 12 volt ground, the red is going to be 12 volt positive, the white's going to be neutral line voltage, black is going to be line voltage hot, okay? And then blue is typically going to relate to something to do with the cooling side. It could be low or high voltage, so you have to pay attention to it. So here it's a low voltage blue signal, which is a cooler signal, and over here it's going to go ahead and power the cooler, so it's cooler related, but it's two different things. Same with the orange. The orange is going to be my number 2 signal. That's typically going to be my heater, and then so the heating digital output from the controller is going to come in here, okay, and then it's going to come out here to after it hits the relay. The relay is going to control this, and then this guy's going to control your heater. Now, you don't have to memorize any of this stuff. That's not why I'm telling you. I'm just telling you so you get an understanding of convention. So when you look at one of my assemblies, you get an idea about how it was set up and a reference to what it means. Again, you see green, you see a green wire, it's generally going to be 12 volt minus. You see red and you see a red wire, it's going to be 12 volt plus, etc. My humidifiers typically run on a yellow wire assembly, okay? So that would be my humidifier in, and that's about all you really need to know about the wiring. You may be curious as to what these guys are. One is an anti-short cycle relay for your compressor. This protects your compressor in case the controller wants to bounce it or wants to come back and reactivate it within a short period of time. So this protects your refrigeration system, and the other is a time delay for one of the fans inside. It's just set up to run a certain way, and this is the timer that delays it. And both these are actually settable, okay? And I'll go ahead and set these. I typically set the short cycle relay at about 4 minutes. And then I have to look back at my notes to see what I'm currently programming this guy for. This uses a number of dip switches to delay start a fan once it's been energized. And again, this is something that can be reset by you if you decide that for whatever reason you're noticing something that's going on in your cooler. Yeah, there might be a way to to help fix that problem. What this generally fixes is if the area behind the back and the evap coil, the cold plate for lack of a better term, gets cold. Before it gets cold, it takes it a minute to cool down, and then what happens is it can throw a bunch of free water into your system. So this allows a delay before that fan starts and throws a bunch of free water in your system. So that's what that guy's for. All right, so I'm going to drill my other hole, and then we're going to get on. We're going to get on to the next thing. This should be pretty much a no-brainer for you guys, or I hope it was. Thanks.